June 1944. Normandy hedgerows. Fog clings to damp leaves. The earth smells of crushed fern and wet clay. A rifleman presses his cheek to walnut, the steel warm from the last burst. Across the lane, an MG-42 chews the hedge into splinters. He doesn't lift his head. He lifts his front sight. Breath in, a clean trigger. The rifle answers with a flat crack and a fast, metallic breath. Gas bled through a tiny port near the muzzle, drives a piston. The operating rod snaps back. The bolt rotates. A spent case flips free. Another round is already waiting. He fires again. And again. No bolt to lift. No rhythm to break. The hands stay on target, eyes locked on a slit of shadow. 8 rounds land like a hammer-tap cadence. A clip springs free with a bright note. A new clip, thumbed in, clicks home. The mechanism never hesitates. Mud on boots, grit on palms. The cycle keeps its promise. What begins at the hedge started years earlier, at a bench under white lamps in a quiet shop in Massachusetts, where a single change to a gas system set this rhythm in motion. The long road to that clean, metallic breath began after another war ended. The United States walked out of 1918 with bolt-action rifles and warehouses of 30 .06 ammunition. The lesson of the trenches was clear. Firepower mattered. The Ordnance Department took that lesson to its bench. In 1919, a quiet machinist with a designer's patience took a desk at Springfield Armory. John C. Garand, Canadian-born, American by choice. He was a toolmaker who solved problems by cutting metal and measuring what the metal said back. His brief was simple and impossible. Give the Army a semi-automatic service rifle that could live in mud, cold, dust, and neglect, and do it with a cartridge already stacked in depots. The 1920s were a laboratory. Garand's first successful path was not gas at all. It was primer actuation. The pressure of firing drove the primer backward a hair. That tiny movement, captured by careful geometry, unlocked the action and started the cycle. It worked, under the exact conditions it was tuned for. The rifle ran well with the 30 M1 ball cartridge, a heavy 172 grain load with a long pressure curve. Then policy changed the physics. By the early 1930s, the Army moved toward a lighter 150 grain 30 M2 ball. It flew fast. It had a different time pressure profile. The primer did not set back the same way. A mechanism built around one curve fell out of time on another. The bench said it plainly. The primer-actuated idea could not be made reliable across the ammunition the Army wanted to issue. Garand shelved it. He went looking for energy elsewhere. He was not alone. The semi-automatic rifle board tested all comers, Pedersen, Thompson, Bang, and more, at Springfield and Aberdeen. A parallel debate raged in brass-bound offices. Should the future be a smaller cartridge? The .276 Pedersen promised high velocity, lower recoil, and lighter ammunition. In trials, a .276 Garand variant ran with poise. In 1932, the board was ready to move. Then the Army Chief of Staff, General Douglas MacArthur, said no. The reasons were hard and practical. Millions of a .30 Aero 6 cartridges already filled the supply chain. Machine guns, training, and industry were built around .30 caliber. America would not abandon its stockpiles. The new rifle would be .30-06. Garand adapted. He embraced gas operation, but not by drilling the barrel. Early ordnance policy feared holes in steel that led the bullet, erosion, accuracy loss, barrel life. So Garand designed a gas trap at the muzzle, a small chamber, and collar that caught the gas as the bullet left and used that surge to drive a long operating rod. No hole in the bore, no interference with the bullet's travel. The theory married conservatism with innovation. The rest of the system took shape around that choice. An 8-round en-bloc clip fed the rifle from the top, simple and fast. A 2-lug rotating bolt locked the chamber. The operating rod, long and slightly curved, tied piston to bolt. A tall, sharp rear sight gave a fine picture out to hundreds of yards. The rifle began to look like the machine that would define a generation, if it could prove it. On 9th of January 1936, the U.S. adopted it. U.S. rifle, caliber .30, M1. Springfield Armory cut steel and taught hands to make the same cut twice. The first rifles left in small batches. Early parts changed fast. Flush nut sights, narrow gas cylinders, subtle stocks. The Army issued them to selected units and schools. Aberdeen kept its stopwatches and notebooks busy. The promise was there. Semi-automatic fire, accuracy on demand, a mechanism that could be learned by feel. Then reality started to leave marks. The gas trap collar needed exact fit and perfect alignment. Fouling built where gas cooled and swirled outside the barrel. Muzzle parts loosened under hard use. Metallurgy and heat treatment for the operating rod were still being tuned. Range dust and line mud told a story that technical optimism could not ignore. By 1940, the need for a different answer was no longer theoretical. The rifle needed the gas sooner, cleaner, and with fewer parts at the muzzle. The fix was small in appearance and large in effect. In early 1940, Springfield and Aberdeen settled the question that had haunted the first production rifles. Drill the barrel. Take gas while the bullet is still in the bore. Feed it straight into a sealed cylinder. Let pressure work before turbulence and cooling waste it at the muzzle. A tiny port near the front sight changed the rifle's heartbeat. The new gas cylinder hugged the barrel. The operating rod's piston met that gas in a short, clean chamber. The stroke was the same long push Garand trusted, but now it began with steadier pressure and fewer places for fouling to hide. The gas trap collar, with its shims and dance of alignment, was gone. In its place, fewer parts, tighter control, better repeatability. Aberdeen's notebooks recorded the difference. With M2 ball, port pressure arrived predictably. Cycle energy was consistent across temperature bands. Dust tests, mud baths, and cold soaks no longer punished the rifle at its front end. The op rod still demanded attention. Heat treatment, radius of the bend, surface finish on the cam. Yet each revision moved the numbers the right way. Failures grew rarer. Parts lifed out on schedule instead of shattering on a calendar no one could trust. The Ordnance Committee approved the conversion. Drawings changed. Gauges followed drawings. Springfield retooled. By mid-1940, new barrels arrived with the drilled port and the revised gas cylinder. Assemblers learned new fits. Inspectors learned new wear patterns. Early gas trap rifles came back to the Armory for retrofit where practical. Not all could be converted. The most troublesome examples were stripped for salvage. The few that slipped through intact would one day become collector-s ghosts, evidence of how far the line had moved. Reliability was more than geometry. It was metallurgy and heat. Receivers, bolts, and operating rods settled into stable heat-treat regimes. Springs found the rates that fed without battering. The clip latch and follower link saw small changes that made big differences to timing. The rear sight grew sturdier, trading early flush nut fragility for knobs a soldier could trust. This was not one invention. It was a chain of corrections pulled taut by a single decision at the muzzle. Production widened. Winchester joined under contract, mirroring Springfield's tooling with its own language of gauges and fixtures. The rifle that left the line in late 1940 and into 1941 wore the same name as the 1936 adoption, but inside it was the improved machine. It cycled smoother on dirty ammo. It shrugged at carbon that would have choked the trap. And it did it while keeping the accuracy the boards had demanded from the first schedules of fire. The Army wrote new manuals. Field stripping drills emphasized keeping grit out of the operating track, a whisper of grease where steel met steel, and a simple truth. Do not take apart what you do not have to. The gas system needed little from the soldier beyond clean ammunition and a steady hand with the clip. The rest was built into the rifle. Rifles like this do not prove themselves on a bench. They prove themselves when the sights cut through smoke and the trigger hand is numb. The Gasport M1 was ready for that moment. The war would oblige it. The war arrived to find the rifle already changed. In 1940, the M1's drilled Gasport turned a promising design into a dependable machine. Aberdeen Proving Ground took the new pattern into its barns and chambers and did what it was built to do: punish it without mercy. Dust fans blew talc and grit into every seam. Tanks of cold air drove metal below freezing. Mud and water worked into the stock line. Timers ticked, counters clicked. The Gasport M1 kept time. The difference came from where the energy was taken. Instead of chasing turbulent gas after the bullet had fled the muzzle, the port drew pressure while the projectile still sealed the bore. A short, sealed cylinder fed a long-stroke piston that was part of the operating rod itself. The result was a clean push with less variance. Cycle energy stayed in the window where springs, cams, and lugs worked best. With M2 ball, the lighter, faster, 30 Aero 6 load now standard, the rifle unlocked when it should, extracted without tearing rims, and drove the next round home without hesitation. Aberdeen's notes captured the practical outcome. Fewer short strokes, fewer sluggish returns in cold rooms, less carbon caked in unreachable corners at the muzzle. When stoppages appeared, they could be mapped to parts and corrected. Heat treatment on operating rods settled into a recipe that bent before it broke. The radius at the cam was eased to spread stress. The receiver rails, bolt lugs, and cam tracks polished into a reliable relationship. Springs were matched to the cycle, so the bolt did not outrun the magazine follower. The bullet guide and follower slide were tuned to keep the stack rising true in the 8-round clip. One change at the muzzle had pulled an entire chain into harmony. The Ordnance Department recorded the improvement in formal language, satisfactory function in dust, mud, and low temperature with approved lubrication and service ammunition, and moved to scale. Drawings became fixtures, fixtures became gauges. At Springfield, workstations shifted to the new gas cylinder, the ported barrel, and the hardened operating rod. Winchester, under contract, aligned its tooling to the same standards, building the same rifle in another accent of steel. Early gas trap barrels were phased out, refits reclaimed usable receivers and small parts. The rest became lessons on shelves. The soldier's manual adjusted with the machine. Grease, not thin oil, for the bearing surfaces that mattered. Don't overclean the gas system. It would take care of itself if the rifle was used and wiped down. Keep the op rod track free of grit. Protect the AND block clips from dents and dirt so they fed like guides intended. The point was not to turn riflemen into armorers. It was to keep hands focused on the few touches that preserved rhythm under stress. Endurance runs began to tell their own story. Thousands of rounds with stoppage counts that no longer drew red ink. Barrels kept their zero better because nothing at the muzzle had to be tightened back into alignment after a hard day. The rear sight matured into a sturdier lock. The stock inletting stabilized. The rifle as a system had finally resolved the compromises that early policy imposed. It was still a precision instrument, but it had become a soldier's instrument. By late 1941, Gasport M1s filled racks at stateside ranges. Fort Benning's Infantry School taught the cadence of rapid fire and the discipline of reloads. National Guard units drilled with a new expectation. An individual rifle could lay down a curtain of aimed shots without breaking cheek weld. Ordnance depots packed rifles for shipment with the same confidence they gave machine guns and mortars. A pattern had emerged: proper ammunition, minimal maintenance, and the mechanism would keep its own promise. Then the clocks of testing gave way to other clocks: convoys, embarkation. New theaters stirred to life. The rifles rolled off benches into crates marked for islands, deserts, forests, and cities. The Gasport system had proved itself in numbers and notebooks. Now it would be judged where numbers were men and notebooks were after-action reports. The first hard verdict came in jungle heat and rain. Guadalcanal, 1942. The 164th Infantry of the American Division stepped onto the island in October with M1 rifles in their hands. At Henderson Field, on the nights of 24 to 26 October, waves of attackers came through elephant grass and along dark tree lines. The defense was a mosaic: machine guns, mortars, Springfield 1903s still in Marine hands, and the new semi-automatics with unblocked clips that vanished into the receiver with a single shove. Under flares and tracer glow, the M1's cadence mattered. Riflemen could stay behind their sights and send a quick second shot into a shape that rose after the first. The gas port system did its quiet work, bleeding pressure inside the bore, keeping the bolts cycling despite wet stocks and gritty hands. In the morning, the line still held. The after-action notes were plain, sustained, accurate individual fire had blunted night assaults that once depended on the moment a bolt gun paused. From the jungle to the desert, the rifle met another test. Tunisia, early 1943. Dust climbed into everything. Sand found the seams of weapons and men. In company-level fights across low ridges and villages, the M1's sealed gas cylinder and drilled port proved less sensitive to grit than the old trap had been. The operating rod's long stroke still ran in a channel that needed care, but with grease where steel met steel, the action kept its rhythm. Interrogations and captured reports remarked on the volume of American rifle fire. German squads with carabiner 98K rifles could answer with precision, but they could not match the number of aimed shots per minute from a line of semi-automatics. In Sicily that summer, as infantry pushed through stone towns and vineyards, the effect became routine. A door opened, a muzzle flashed. A fire team answered with a fast series of hits without changing their hand position or breaking cheek weld. The weapons mechanics had become a small unit habit. The tactical dividend was not magic. It was seconds shaved from every exchange. In a hedgerow lane in Normandy, June and July 1944, those seconds were life. Hedges split the country into rooms of earth and leaf. Enemy riflemen and machine gunners waited behind cuts in the green wall. The first hint was movement in a slit, then a shot from a black hole you could not approach in the open. Here, the M1's gas system paid its debt. A soldier could fire, see where the front sight sat when the rifle settled, and fire again without breaking position. If a target flinched back into shadow, the next round was already in the chamber. If another head rose along the hedge, the rifle moved with the eyes. Teams learned to pin a threat with fast, aimed fire while another element worked around a corner. Sometimes the opening was only a breath long. A bolt gun asked for a hand to come off the stock. The M1 asked for a decision and a press. Not every unit wrote about it. Many simply used it. But patterns showed up in reports and training circulars. Company officers described firefights where the first burst from semi-automatic rifles seized the tempo and held it. Platoons noted fewer openings for counterfire when their rifle lines kept a constant beat. Ordnance officers in theater tracked repair returns and saw what mattered. Barrels washed out by hard service stocks, cracked by rough handling sites knocked, but gas cylinders and operating rods from the gas port pattern rarely came back for fundamental failures. The system that mattered most to the cycle was not the system that failed. By late 1944, the reputation had climbed into the language of generals. George S. Patton, who measured weapons by what they did to an enemy's will, called the M1 the greatest battle implement ever devised. The line is often quoted because the field had already said it in other words. The rifle let infantry reclaim the moment after the first shot. It knit squads together with a rhythm they could trust while moving, while bounding, while crossing a lane under fire. The gas that bled through that small port at the muzzle was the quiet author of that rhythm. The enemies adapted where they could. They increased the use of machine guns and mortars to break up advances. Snipers worked the gaps and waited for reloads that came 8 rounds at a time. But the baseline of fire on the American side had become something different. It forced changes in how opponents approached, how they arrayed their weapons, how long they risked a silhouette in an opening. It changed how American leaders trained men and how factories planned parts. From Guadalcanal's soaked wire to Tunisia's dust and Normandy's walls of green, the verdict was consistent. The ported gas system made the rifle keep time when time was most contested. That consistency invited something larger, new ways to teach, to equip, and to fight on foot. The rifle did not end firefights by itself. It shifted how those fights began. In rifle companies from New Georgia to Normandy, semi-automatic fire became the baseline, not the exception. Squad leaders learned they could seize the first seconds with a wall of aimed shots and hold them long enough for a flanking team to move. The bar still anchored the element, but the rest of the line no longer waited for a bolt to lift and fall. The gas-port M1 made fire superiority a habit rather than a plan. Training followed. War Department manuals and films taught rapid, controlled strings, reload on the move, keep cheek weld, drive the sight back to the same front post. In close assaults, some units practiced marching fire at ranges where seconds mattered more than sight refinements. It was not wild. It was deliberate pressure, steps forward with a rifle that would not pause between shots. The psychology changed as much as the geometry. Men trusted that a second, third, fourth round would be there without thought. That trust freed attention for terrain, for flanks, for signals. Supply met the moment. By VJ Day, Springfield, Armory, and Winchester had produced just over 4 million M1 rifles during the war, roughly 3.5 million from Springfield and about 500,000 from Winchester. The Flow Titan Doctrine. Rifle companies were equipped on paper and in fact. Replacement pools were deep enough to keep units whole. Parts, clips, and grease followed rifles through depots to the front. The system from port to piston had become a repeatable industrial act. Maintenance became simpler where it counted. FM 23-5 told soldiers to keep the gas parts alone unless they had a reason. Wipe the rifle. Grease the bearing surfaces, the operating rod track, bolt lugs, hammer hooks. Protect the clips. Check sight knobs. Armorers watched the small things that could trip timing. Follower arms, bullet guides, springs that tired. The op rod saw its own refinements. Heat treatment that bent before it snapped. A gentler cam radius. Relief cuts that prevented binding as barrels warmed. The rifle did not need devotion. It needed respect. Adaptations multiplied as infantry made the rifle do more. The M7 grenade launcher gave every squad more reach without calling a mortar line. A dedicated grenade cartridge and a gas cut-off lock screw kept pressures where they would not punish the operating rod. Sights for grenades and doctrine for teams, 2 rifles, 1 spotting, grew from experience. It was untidy at first. Then it became routine. The rifle that kept its own cycle could be asked to launch steel from its muzzle and still return to its cadence. Factory floor and firing line kept talking. Reports from Tunisia, S-Dust and the Hurtgen S-Cold, came back to Springfield as changes to drawings and gauge limits. Barrels and cylinders were held to dimensions that preserved port pressure as erosion set in. Stocks were bedded and reinforced to resist swelling and cracks. The rear sight's lockup evolved into a unit that stayed true when knocked. Winchester's line mirrored the improvements, proof that the design had matured past the personality of a single shop. None of it made the rifle perfect. Mud could still seize a follower. A dented clip could trip a feed. A tired spring could lose a step in winter air. But the core cycle, the sealed port, the short chamber, the long stroke, was hard to bully out of time. That resilience let rifle companies plan around certainty, and it turned the semi-automatic from a novelty into a standard. When a standard sets, others notice. Across oceans, engineers pulled captured rifles apart and measured what America had decided at the muzzle. They pulled them apart on benches and traced the pressure path with calipers. Germany began with a rule that mirrored early American caution. no hole in the barrel. The result was the G41, two rival models from Mauser and Walter, both built around a muzzle gas trap that harvested energy after the bullet left the bore. It looked tidy on paper. In service, it was heavy, front-loaded, and dirty. Carbon collected where turbulence lived. The rings and cones fouled and seized. In North Africa and the East, the rifles needed attention a rifleman could not spare. Production stumbled, and field reports were blunt. Then the Germans did what the Americans had done in 1940. They drilled the barrel. The Gewehr 43, later redesignated Karabiner 43, arrived with a short-stroke gas piston and a clean port near the front sight, an approach learned in part from captured Soviet SVT rifles. The G43's 10-round detachable magazine, lighter front end, and simpler gas system cut the failure rate. About 400,000 would be built by war's end, but the rifle fought uphill against late war materials, hurried machining, and the pressure of a collapsing industry. It helped, but it did not remake the fire discipline of entire divisions. It came too late to become a nation's baseline. On the other side of the front, the Soviets had tried to make semi-automatic fire the norm even earlier. Elsewhere, ambitions ran into limits. Italy fielded small batches of self-loaders, the Armagera mod, 39 among them, without the scale to matter. Japan studied captured M1s and produced prototypes of the Type 4 self-loading rifle in 7.7mm, a Garand-inspired weapon with a different feed system, but only a handful were completed before material shortages and the war's end closed the chapter. Britain and the Commonwealth, adept at mass-producing accurate bolt guns, kept the Lee Enfield as their backbone while exploring self-loading designs that would mature only after the war. Germany's parallel answer to the American rhythm was not another full-power semi-automatic, but a change of cartridge, the Sturmgewehr, an intermediate-round automatic rifle. It solved a different problem. In the specific contest of full-power, general-issue self-loaders, the United States alone managed to arm entire infantry formations with a reliable, repeatable mechanism and keep it fed and maintained from basic training to the line. The lesson cut across borders. Gas trapped in turbulence at the muzzle made promises on paper and broke them in mud. Gas taken through a clean port and tamed in a sealed cylinder delivered pressure where geometry could use it. When paired with industrial discipline and clear field doctrine, that small choice translated into hours saved in maintenance, stoppages prevented in cold or dust, and seconds won in fights measured in seconds. By 1945, the sound of American infantry fire, from the Hurtgen S wet pines to Luzon S tangled fields, carried the same, even cadence. It came from a tiny hole by the front sight and a piston that did its work without drama. Which leaves one last question. What did that choice mean for the people who carried it and for the wars that followed? It meant that a rifleman could count on time. In a trade where seconds decide, the gas taken through a small hole near the muzzle gave those seconds back. Not invincibility, not magic, just a mechanism that kept its own promise when hands were cold, wet, or shaking. That trust changed how men moved, how squads talked with fire, and how leaders planned the first violent moments of contact. It also meant that engineering, policy, and supply were not separate stories. The 30-06 decision forced a path. The primer-actuated idea fell away when ammunition changed. Early caution about drilling barrels wrote the gas trap into metal, and the mud wrote it back out. The port brought pressure into a sealed space where geometry could use it. Heat treatment, radii, springs, and sights followed. None of those decisions lived alone. They were a chain that began at a bench and ended in a hedgerow. For the record of war, the M1's steady cadence reset expectations. An army armed not by exception but by standard, with a reliable self-loader, could meet an enemy in the open or in a doorway and keep the moment after the first shot. Opponents took note. Some chased the same idea with their own ports and pistons. Others answered with different cartridges and doctrines. but the baseline had moved. After 1945, a service rifle that did not harvest gas cleanly at the bore was the outlier, not the norm. The lesson is quiet. Test until the numbers hold in dust, cold, and heat. Make the part that matters simple to live with and hard to bully out of time. Teach only what a tired soldier needs to remember. When all of that meets in one design, the result is not a headline. It is a rhythm that frees attention for the things that decide a day. Picture the last image. A white lamp over a Springfield bench. A barrel in a fixture. A bit breaks through and leaves a perfect circle of steel and light. Years later, a rifleman leans into a stock, hears the flat crack and the soft, mechanical breath, and stays on his sight. Between those two moments lies the small choice that made the rifle rule the fight, and the calm certainty of a cycle that refused to stop.